Hello and good afternoon, good morning, good evening, wherever you are in the world. I'd like to welcome you to the latest BitGardener web seminar. My name is John Kowalski. I'm part of the marketing team here. Take screenshots, share it with colleagues, whatever you like. Also know any of the marketing messages you receive. If you have a question, just hit reply to any of those. It'll be funneled to me and my team, and we'll route those to the right technical specialist in your area. So with that, let me introduce our speaker today. He is our business line manager for our VMA Getzman business, Mr. Jonathan Bain. Hey, JB, how are you, sir?
I'm doing well. Thank you, Johnny. Appreciate the opportunity to talk here today. And I appreciate everybody taking the time to join us when we talk about when torque tells the truth. We have, we get the feeling from customers and even with our own production that you want to be more, a lot more efficient in what we do, right? We want to shorten, the time that it takes to produce our materials, and we want the quality to go up. Well, in dispersion, there's no difference in that scenario, right? So we want to shorten our dispersion times. We want to gain a real knowledge into how the materials are performing to be more productive. And the easy way to do that, we have found, is the real-time torque measurement. So we like to say that torque always tells the truth, and that's what we're going to talk about here today, of how you can incorporate torque measurement into your dispersion processes that will definitely help you. So the agenda, we're going to talk a little bit about dispersion flow characteristics. We're going to talk about
You there, JB? You there, Jonathan?
I'm here. I'm getting it blocks off.
Weird. Okay. No, I think I can hear you now. There's something going on with my audio too.
Yeah, I'm having some audio difficulties. I apologize for that. But so while I got you, we're going to talk about the dispersion flow characteristics, what is torque, why it's important, the TMS sensor and why you need it, and we'll look at some batch curves to finish up. So the dispersion flow characteristics is typically there's two different ones that we see in dispersion, but it basically determines your shear profile and your energy input. How much energy can you put into your material based on its flow characteristics? This will directly impact the agglomerate breakup efficiency. So when you think about a low viscosity product versus a very thick product, how differently do they perform throughout the dispersion process? Heat generation is a big one with regard to characteristics. We always want to make sure that we're protecting our material and having a good idea of the flow characteristics and the way it reacts is a good way to do that to make sure you're protecting your material from any heat degradation. This will go across all of your different your flow characteristics affect your lab to your pilot to production. So it really doesn't matter what your volume is. You really need to pay attention to your production. I mean, to your flow characteristics. And of course, this is critical to your repeatability. So the first we're going to talk about is laminar flow characteristics. This is characterized by a very smooth, layered fluid motion. You can see in this picture here that shows a good dynamic of your donut. The donut effect is what we call it, and this is a very stable formation. You have to have enough structural integrity in your viscosity for this to form when you're putting energy into it. It's a very good visual cue of the dispersion process. So typically in most applications, when we see a donut, we see very good dispersion results. Now, that's not to say that if you don't have a perfect donut like this, that you are not being successful in your dispersion process. It kind of varies for application to application, but when you do see this, you can be guaranteed that you're getting a good dispersion. Of course, like I said, it's very viscosity dependent. So there's a lot of materials that are just too thin to produce this kind of donut or this fluid laminar flow, simply because it lacks the structural integrity to form that way. And when it does that, especially on when you start putting a lot of energy into it, and when it does that, we get what we call turbulent flow characteristics. So that's very chaotic. It's a very irregular motion. It makes different kinds of noises. Like it's collapsing onto itself just because it doesn't have the viscosity to hang in there, especially on high speeds. So you do get a lot of kinetic energy dissipation or conversion when you're in this stage, and you get a faster solid incorporation. Now, that solid incorporation just means from a mixing standpoint, we're not deagglomerating very well at this particular stage. So you want to be cognizant of your flow characteristics. So what is torque in dispersion? Well, torque is the twisting force that goes from the motor through the shaft and the impeller down into your product. So how much of that twisting force are we imparting into your product? It creates the pumping and flow mechanism that gets the movement. It's what to overcome resistance. So especially when you're talking about high viscosity materials, it's torque that powers you through and keeps you from stalling out or damaging your motor. The measurement of torque really helps us with the scaling and the efficiency. So being able to keep a good eye on how the material is or performing really helps with the scale up and efficiency. It allows for accurate measurement in real time. So we get real-time process monitoring, and it creates measurable process fingerprint that makes it repeatable, right? So everybody has individual fingerprints that identify them on an individual basis. Well, if your torque measurement is set up right, it can do the same thing for your product. So you can look at a curve, a torque curve, and know exactly how your product has been processing throughout the process. So why does torque matter? Well, it gives you instant feedback. real-time changes what happens inside the batch. You can't see under the water level or the material level, so you don't really know from a visual what's going on. It helps you to be cognizant of your input trends throughout the entire process, whether that be from wetting, during your wetting phase, your deagglomeration phase, and your stabilization all the way to the end. And again, I will say there's going to be some things here that are repeating, and that is on purpose, because we want you to understand how everything ties together. So when you don't think that we're being repetitive just for the sake of it, all of these things tie together, and you'll hear a lot of these things over and over. It helps ingrain in your mind. So, but again, repeatable process fingerprints can help you with your repeatability. So the two different ways that we get this information, most instruments will have some sort of frequency inverter or VFD, and that's just measuring the electrical effort that the motor is exerting, right? The problem with that is that can't distinguish from mechanical efficiencies, things like bearing friction or seal resistance, or maybe a gearbox in efficiency. Where we have what we call loss gaps. That leads to low accuracy with regard to the data. So especially at lower speeds, these high-speed dispersers are designed to operate at very high RPM, so they're really not geared from a calculated value to be very accurate at low speeds. The one thing that it does do fairly well with regard to calculated values is it allows you to isolate variables. So what happens if I change the RPMs or the size of the blade or the speed? So it can help you with predictive models, but from a QC, an R&D, or a quality control standpoint, it's not as accurate as you would like. So you can produce the same material over and over. And the way we do that is by a direct measurement. So the direct measurement is measuring the applied force down through the shaft and into the impeller. So it's much more accurate. And this all happens in real time. So this will help you eliminate some of those parasitic losses, those mechanical inefficiencies that can cloud the data with regard to a calculated value from a frequency inverter. So it's highly recommended measurement of torque be used in your process. We like to say that the torque is the truth, and that's an absolute truth with regard to how the performance of the machine is going and how the performance of the material is going. So very important. So what do you experience in labs today? Well, you have different machines from different manufacturers in your lab and your pilot and your production, and they all behave differently. You have batches that you may think from a visual aspect, they look pretty good, but when you analyze them, they're not where they need to be. Operator intuition, right? You have guys working these machines, or guys or gals, excuse me, that have been working these machines for a long time, and they kind of get their own set way of doing things. That doesn't often lead to increased accuracy or increased repeatability. It also, what you're unclear of a lot of times is what causes a batch to fail or drift, or inconsistent energy input. So being able to remove a lot of these things that happen today is a bonus for everyone, just by simply measuring torque accurately. So the integrated measurement system, the TMS, measures the torque with high accuracy down to a resolution of 0.01 nanometers. You get this in real time. It gives you precise viscosity curve tracking, so you get your fingerprint. Repeatability, it makes it repeatable across all operators, given that the parameters are set. And you have recorded data that will allow you to transfer into a scale-up situation. So what are we actually measuring? Well, we're measuring the actual resistance in the batch. So how much material will stand before you damage it, right? So We don't want to damage our material. Material is expensive, and we're trying to make money on selling it. So we definitely don't want to destroy it. It shows you, measures the viscosity in real time. So how is the molecular structure of the material changing based on the pressure or the stress that it's given to in the shear? Particle wetting progress, how is it interacting with the solids and the liquids? How are we wetting this out? Is this an efficient process? The efficiency of shear and impact, we don't want to damage the performance of the material by over shearing it. And then all of these aspects put together lets us understand how these factors are working together to produce our product. This will help us improve our quality and reduce our waste, which will increase our profitability. So why is torque measurement critical? Well, a number of different reasons. So we have our viscosity control and stability. So this will ensure us how we make consistent or material properties for uniform coatings. Dispersion and homogeneity, this helps us optimize our shear forces for proper breakdown of our materials. Process efficiency and scale up, this just takes all the guesswork out of the scale up process, going from the very small lab volumes up to your production or pilot to production volumes. It helps remove a lot of the guesswork there. Avoiding over processing. So we don't want to over process our material. We want to protect it. We don't want any kind of degradation or excessive shear on our materials. This is how we can control that. Equipment load optimization. I think this is really important, especially since we're in the instrument business. You want to protect it, right? You don't want it to overload. You don't want to expose it to excessive wear on your equipment. So that's a very important feature of the torque measurement in itself, is to protect your investment. These are not cheap instruments. People spend a lot of money on this, and they need it to be a workhorse, and they need it to work for a long time. So this is a good way to do that. And then finally, quality control and reproducibility. This is how we ensure our process consistency. From batch to batch, all the way from start to finish. This will improve our consistency and help improve our product performance, which will in turn make us more efficient and we will be more profitable, which everybody is trying to do. So with a simple TMS sensor or torque measurement, we can accomplish all of these things. So controlling viscosity in real time. So you get to see on the graphs the material, how it responds. Is it getting thicker? Is it getting thinner? You can show it will show you when the energy input is, we're getting a good process. We're getting that de-agglomeration phase that's readily available from a graphing standpoint. You can see how that material is processing. It really helps you define your process windows. So how long are you going to disperse it at what particular speed? Or energy input. All of these things are variables that you have to work out, and being able to control in real time how these things process out with the data that you get from measuring torque helps you do that. It also will help you reduce the variability for temperature. So we know thicker materials can heat up due just to the friction alone of the shear. So you want to maintain your being able to keep a close eye on the temperature control as the material is processed, so you don't do any damage. And then it all promotes consistent performance, which is what we're all after. Batch quality, minimizing thermal drifts. We talked about that just a second ago. We can reveal agglomerate breakdown, right? Either early or extended. Based on how the torque measurement flows up and down based on where it is in the cycle. We avoid the sensitive materials, and we prevent over particle size targets. So with each application, you will all have desired primary particle sizes, and If you exceed those particles or you make them too small, maybe that changes the way that the functionality of your material, your coating, and that's not a good thing. So we definitely want to make sure that you keep a good handle on where you are in your particle sizes. Torque measurement allows you to do that, and again, produces traceable process data. Being able to find out where something went wrong is very important, right? Have a spike or a drop in torque for any particular reason. There's any at any particular time during the process, you can find that in the data and do some investigative work to figure out what caused it. So over time, when you see these kind of responses, you know where to look and what the culprits might be. The advantages of process efficiency. Well, it helps us identify the point of diminishing return, right? So any material given any particular shear force will get to a point where it's not going to change anymore. And once it reaches that point, you want to stop, right? You don't want to just keep over processing. So being able to identify that is critical during the process. This will shorten your cycle times. It reduces your energy use, which makes your production costs go down. It improves the life of your equipment, and then it also supports continuous improvement. Right? You can look at the data and you can see where you can perfect the process. We don't want to cut corners. We want to be exact, and torque measurement process efficiency allows that. So. Processing mentioned earlier, the plateauing effect, the diminishing return. We want to make sure that we're not exceeding the limits of our particle sizes or the material. We can control the amount of shear over the lifetime of the entire dispersion process, from the wetting to the deagglomeration all the way through. We work with constant speed and constant energy with regard to our machines and functionality. And that's important because we can dial in a set number, either an RPM or an energy input, that will automatically react to the change in the material to maintain those constant speeds. This is really important in making sure consistency is key. Again, we reduce scale up, any kind of scale up surprises going from smaller to larger volumes. Scale with confidence. So the torque curve, it's very much like a spectral curve for all of you color and appearance people. The spectral curve identifies the true color from the 400 to 700 nanometers, right? Well, a torque curve kind of acts the same way. If you and you get your process really dialed in, that torque curve is transferable to larger volumes, so you want them to look the same. So you're basically matching your energy profiles between your lab, your pilot, and your production scale product runs, and this reduces the scale-up surprises. And what it also does is it improves the predictability when material shifts. So, like I stated earlier, when you get when your data shows that you had something happen, either a spike or a drop, you'll kind of be able to look at that and this, all of this leads into scaling up with high efficiency. Equipment load insights, right? We want to make sure that we're taking care of our machine. The demand based on the torque measurement should be the same across all your different formulas and different volumes. So this will help us prevent our overloading. It reduces stress on the motors and the bearings, all the wear parts, to make your machine last longer, which extends the equipment life. Excuse me. So repeatability you can buy. So this is how you make the best products that you can possibly make. Consistent, repeatable energy input, formulation, verification, and performance. So everybody has a lot of different materials that they make. Well, each one will have its own performance profile. So being able to program in how these things are processed from a machine standpoint, with your set your RPMs, your watts and energy, all of these things that have been proven out. Well, that just aids your repeatability. So being able to operator to be able to call up um, a recipe for whatever the product may be, and just basically hit go and have it repeat the same process over and over and over again. That's only going to make your products more efficient and more cost effective. You get early detection and errors of errors, right? So the machines will tell you if something's off. This will lead to reduced material waste, which lower your costs and increase your profitability. Again, we talked about optimized process scaling. It makes it really easy to I wouldn't say easy, but it makes it easier. It takes guesswork in the scale up process. The machine safety and compliance, and making sure that your machine is not overburdened. And then again, the viable material fingerprint. So the modern control system, what are we looking for, right? We're looking for real-time torque graphs. We want to see what the material is doing when it's doing it. The programmable speed and energy profiles that match each formulation. Again, the recipe storage, being able to recall multiple recipes and produce the same product over and over. The ramp up functionality with the PLC controllers, a completely hands-off process for operators. It allows you to set every stage with your time, the amount of energy you put in, the RPMs, and it will automatically adjust throughout the process by itself. With the PLC controller. So it's a great function. It is an added cost. In a lot of cases, customers think it's worth it. In a lot of cases, customers don't think it's worth it. So I'll let you decide, but that functionality is an excellent way to take away any kind of human touch with regard to automatically producing these products. You have good safety and default detection. You want to know where the errors are coming from, what's happening, and then having options. With our product line, everything is modular. So a single disper mat can become a vacuum disperser. It can become a vertical bead mill or a basket mill, or a homogenizer with just a simple swap of a head or an attachment. So being able to be flexible and have multiple operations with one machine without having to buy extra machines is an added bonus. And I've been in 1,000 labs. One of the things that a lot of customers bench space. This is a really easy way to cut back on your bench space and really have a lot of options and flexibility to increase your productivity. So what does this mean for you, right? What is all this torque measurement, and why would we do this? Well, it produces less variability. It produces shorter cycles, predictable scale up. You have confident and competent operators, right? Everybody knows how easy it is to use, and they feel confident in doing so. You get the consistent batches. You make data-driven somebody's idea of what they think might work. That you can look at the data and know exactly what you have to do. And again, repeated, increased profitability, which what we're all after. So without TMS, with TMS. So without the TMS, you can have visual miscues, right? You can get incomplete product incompletion. You have mismatches in scale up, makes it very difficult. A lot of guesswork, trial and error. You can have unnoticed thermal drifts and unclear failures, which is a big part of this, right? Being able to recognize where to make the adjustments or what went wrong is critical in your efficiency. That kind of situation can be a very, very big time suck, if you will, or time eater. So being able to get through that fast really, really helps. So with the TMS system, we get real-time clarity, right? We real-time what's going on. We know for a fact when the material is properly processed and completed. It's a very smooth scale up process. We get early heat and shear detection to protect. If we do detect an error or an issue, we know where to look, and we know how to find it and fix it faster. So what we're looking at here on the torque curve, right? So we have an initial spike when we start to add our solids. That will decline as it wets out, right? It kind of evens out, and then we will have, when we get into the dispersion phase, when we're adding the tip speed of getting to 18 to 25 meters per second, we also have spikes, right? But what we're looking for on this is that it does stabilize, that we get an within each stage. That means that's showing us that we're getting good material processing. When we have variables, that means our material is reacting differently, or we're having temperature shifts. So looking at this graph here, most of these are I would say pretty stable from a processing point of view. We do have a couple of lines that came across some difficulties there. Right there in the dispersion phase, and that's typically when we don't have complete deagglomeration. So when you think about what's happening inside with regard to the torque and the impeller blade, if it's going along at a certain clip, and all of a sudden it comes in contact with maybe some agglomerates that haven't properly been broken down, that will increase your torque. So these are the kind of things that you can look for on the torque curve. So what does a good batch look like? Well, this is a very good batch. You see how stable it is at each when we raise the RPMs or the energy input. You see a nice stabilization very quickly, and this is exactly what you would be looking for when you are processing your material. So it's repeatable across all operators. That's one of the greatest things, right? These things aren't going to, if you have it dialed in correctly, you're not going to see wild graphs based on anything that the operator did, or if he did do, he or she. I apologize. Anyway, that's what a good curve looks like. So what an abnormal torque pattern looks like. Well, we have, we could have flow characteristics issues. We can have air that's trapped or deagglomeration. You can see there on that red line how that dropped way off. I'm not exactly sure of what material was being run here or what caused that, but these are the kind of things that happen when either the material drops in its viscosity. Maybe there's air. It's not a vacuum application, but you see, how the material, how the graph really responds and gives you an idea what's going on inside the vessel. So if you have extended high torque, that means it's either an incomplete wetting or your viscosity is increased. If you get plateaus, early plateaus where it doesn't spike up hardly much at all, you're either not putting enough energy into the process, which means your tip speed is too low, and you're basically just mixing at that particular stage where we're not deagglomerating. And then if you have your drifts between your batches, you get you have material variations depending on the formula. So torque based troubleshooting, rising too long, right? The torque continues to go up. We're getting resistant agglomerates and pre-dispersed long enough before we got to the deagglomeration phase of the process. You want to make sure you give each of your segments proper time to get the material in the state that it's ready to move forward. So if you stay high in that torque range for too long, you're getting more resistance than you probably want. If it falls too fast, we've either over sheared or we have thinned the material. Maybe we put in some extra liquid that's causing the viscosity to drop. If it's unstable, materials can react differently from a temperature standpoint. That can cause it to go up and down. A lot of times with a low torque, what you'll see is that or with low torque, your blades are not properly sized for the vessel, so you're not able to import enough energy into the system, and then with high torque, you get flow restrictions from high viscosity products that may be causing a viscosity spike. So corrective actions, we can always adjust the energy input to match the shear needs, right? We're watching it to see how the graph, the real-time display is performing, and if we don't have the capability of constant speed or constant torque or energy, we can adjust that as necessary. This will help to stabilize our temperatures, which will aid in the flow characteristics. If we need to modify the bead load or the vessel fill ratio, right? This is a critical part of dispersion, is making sure that we have our parameters set properly with regard to our blade size compared to our vessel size and the appropriate fill rate. If you have too much or too little, all of these things are going to affect the way your material is processed. And if we need to, we can order the way the addition. We see this a lot when we do our lab trials, that maybe you add a particular material in a particular order that has an effect on how it begins the process, but it can also affect how it processes out altogether. So maybe improving the order of the addition of the material could be something to look at. And then if we need to, we can adjust formulation ratios if possible. So a couple of things that you can do there. The scale up blueprint, again, we talked about the fingerprint, right? So you're matching your torque ratios to your speed ratios, and how your materials perform against those gives you your fingerprint. And we're this is how we match from smaller to larger volumes. We're aligning our input profiles. So we compare the shapes across across all volumes, right? Whether we're doing 500 milliliters or 10 liters or 500 liters, right? The shapes should remain the same given the parameters are set properly. Each fingerprint or signature that you document, it is evidence, right? It's evidence of how the process went, and this is how you really dial in your repeatability. Predicted mechanical and thermal response. So we know over running our batches in the smaller volumes, we should have a good idea how the temperature it fluctuates depending on the amount of shear force that's being put in, and that will allow us to scale up as well. Because given everything's the same or in order, from a parameter standpoint, and the performance should be the same or close to it, right? You're never going to get exact one-to-one, but you want to get as close to that as possible. So a lab curve, production curve comparison. The lab curve, you define the targets, right? You figure out the most efficient way to process the material, and that creates the fingerprint. Then you validate that against your production curve. So you keep adjusting your production output to match the curve of the lab, right? So having that defined lab curve really, again, takes out a lot of the guesswork when you're trying to achieve the same production curve. You'll have deviations from lab from the lab to production, and most of the time that's a flow or geometry issue, right? So maybe your fill ratio is wrong on your lower volume. You don't have a big enough blade. So all of these things come into play. That's typically where you will see the differences, while you're dialing that in. But the match curves produce match QC results. So your QC or your R&D exercise, the produced material, if things are correct and your curves match, then you should get the same results. So operator experience with modern controls, the live performance graphing on all the parameters, right? So with our control system, you get trend lines for your RPMs, your watts and energy, the torque measurement itself, and your tip speed, along with your timer function and thermal coupler, right? Your temperature readout. Having all that displaying in real time makes life really easy for operators. The ability to store the formulations, really helps, right? You can just pull up whatever it is you're working on. It's already been set. You've produced many batches of that successfully, and it's going to happen again. We talked about the PLC ramp ups. That makes life even easier. But you get the full process logging, right? You get it from start to finish. You have every data point along the way. It really aids in repeatability and efficiency. You can protect your machines with the system alarms. You're not going to overprocess. You're not going to overprocess material. You're going to damage your machine. And with the automated correction, with automated functions like constant speed or constant energy, the machine does it for you, right? So if your material changes, the machine automatically adjusts to compensate for that change. The impact, the ROI, well, it's about money, right? We shorter cycle times, less rework wasted materials. We have lower energy use, so our profitability has gone up with that material. Faster root cause analysis, so if we have issues, we know, and then we get more predictable, more repeatable QC outcomes. So how do we get started? Well, I would start with a high variability product, something that may be a problem product that you have, that you run a lot, right? You map out your dispersion stages. How long are we going to add material at what speed? When do we go into the deagglomeration phase? Map all of this out. You define your process window, right? From start all the way from start to finish. Then you run multiple torque log batches. So you get your fingerprints. You start to compare those fingerprints. You apply, once you get it nailed in, you have the ability to scale up from there. So it's not that complicated a process. And despite all these different steps, it can be a pretty quick situation. Bringing it all together. Torque is honest, truth, feedback. It eliminates guesswork. It gives you clarity and control over your processes, and it supports confident scale out. But this is what I think is really important point, is that it strengthens your technical leadership, right? At data, you're making data-based performative decisions. So like I said earlier, we're not cutting corners. We're trying to be exactly as professional and efficient as we can with our processes, and having this data readily available makes that happen. And it basically gets everybody on the same page. And when we all work together, things turn out better than not. So I think that's a real important aspect to this. So thank you guys for listening. That's about all I have. I do want to mention that we have, I know a lot of you may be familiar that we have lab instruments, but we have the capability to have this technology all the way through production, very large production machines. And it's the same technology that you would get on a small lab instrument. So the transfer is very easy, and you're basically talking the same language. So we have that capability. If anybody's in the that situation where they're looking to scale up, we would love to talk to you guys. But again, thank you for your attention and your time. We appreciate it.
Great stuff, Jonathan. Really good. I mean, this is a whole new level of information that I'm getting. So thank you for sharing it with us, sharing your expertise and explaining it. So like even a marketing guy like me can understand. So, I I wrote down several things from your presentation, and I'm just gonna, you know, read them out here, point on them. If you want to expand, great. If not, let me just keep going. But one thing that really stood out that you said, we don't want to cut corners. We want to be exact.
Yeah.
And this technology, and correct me if I'm wrong, this technology allows that exactness due to the real-time data, the real-time graphs that continually monitor everything going on, with the machine, but more importantly, with your material. Is that correct?
That's right. It's data-based reaction, right? It's not, and not to diminish the skills of people that do this on a daily basis or have done this for a very long time.
Yeah.
But you're right. You're basing your decisions and your actions on data with predictive outcomes. So act with the data, again, it streamlines everything, right? It makes all the guesswork, everybody's heard me say this over and over, but a lot of times that's what this stuff is, right? It's it's trial and error, if you will, if you don't have this kind of technology. So yeah, in that instance, you're going to have to go back. But with this technology, it really eliminates a lot of that stuff, and you're driving everything by data.
Yeah, and you mentioned error or operators. You're getting a variety of operators on a varying shifts, and each of those operators have varying levels of experience. So once you dial in that exact fingerprint and those exact settings, you're removing any potential for those operator variables or inconsistencies, so you're getting that repeatability.
Yeah, that's right, John. And on top of that, if there is an issue, right, if there's a problem with the batch, most of the time you'll see that in the data when it happened, and you'll start to dial in as to why, very quickly.
Yeah.
So what caused it to do this?
Was
it a bad agglomeration? Was it an air bubble? Was it a dilution? Did we put more material in? All these kind of things that you would have to fumble through to arrive at an answer. The data will tell you.
Yeah, I'm just going to flip to a slide here with the data. I mean, you're able to watch every stage of the dispersion process and look for those little blips, those trouble areas, so you can immediately jump on that and solve that problem to make sure you're not wasting all that material.
That's right. Yeah, I mean, able to see it from start to finish.
Yeah.
And how it reacts is ultimately what you're looking for is the good pattern, right? The recognizable pattern. But in the event where you don't have a recognizable pattern, you have you have things that that will have been the culprit. So it all leads to streamline and increased efficiency.
Yeah, and I love how you brought it back to one of the last slides, the ROI. That's what it comes down to. Optimizing your process, reducing scrap and waste, but it's ultimately leading to your customer satisfaction with the best possible and repeatable product. And that in turn, from my side of things on the marketing side, that in turn boosts trust with your customer.
Yeah.
And, and that goes so far.
It does. It's what keeps customers coming back.
Yeah. Amen to that. No,
and
really,
we're all in this business to make money, and increasing on the efficiency, lowering the cost of production. All of these things add up to making more money for all of us, and that's what we want to help customers do. And we welcome the opportunity to talk to anybody about any of this.
Yeah, exactly. Jonathan and his team, we have technical specialists all over the country and all over the world, really. And, we're available to help you optimize this process to make sure that you're dialed in just how you need to be. We have Dispersion Lab in Wallingford, Connecticut. A lot of customers are in and out of there all the time testing material. If you're interested, reach out. We can schedule a trip, get you in there, have you ship some product, and do some real world testing on the equipment just to see how that works.
It helps, I tell you.
Yeah. Hey, one question. Jonathan, you're out in the field. You deal with customers all day long, every day. When it comes to this topic of torque, what do you see, or what have you seen in your experience being the majority of issues or challenges, or just things that customers are doing that they could, look at and optimize?
Yeah. So from my experience, what I see, well, with regard to torque, and that's kind of why we want to do these kind of seminars, to get people trained into the idea that the torque measurement or the torque factor of the dispersion process is super important. What I see most often is people are just stuck on RPMs, right, of the dispersion process. Well, that's only one part of the equation, and your RPMs is only good if you have the correct tip speed, right? So and that's an equation based on the RPMs times the diameter of your dispersion blade. Yeah. So I want to get the torque aspect more readily thought about and concerned for in labs across anywhere, because this is really where you dial it in. I mean, you can change the blade size and the tip speed all you want to, but if your material's not, if you're not seeing how your material is actually performing to those changes, then really what are you doing? And these are the kind of things that we see on a daily basis, that it's not just the RPMs. There's a lot of things that go into this to get it right. You're only focused on just one small aspect of it, then you're missing the boat.
Yeah. I mean, you're absolutely right. So again, what was one of the last slides? Getting started with torque.
Yeah.
I love this. So, everyone out there, take a screenshot of this now, wait for the recording, but this is a good way to, kickstart your process, number one, or two, review the current process you have in place and making sure these steps, are methodically followed.
Yeah, for sure. Like we've repeated many times, but it's a fingerprint. It's a fingerprint for success, just like a spectral curve is for matching color.
Yeah, and I never thought of dispersion like that, but you are absolutely right.
Yeah, it really is. And really, it's really not that complicated. It's just one of those things that a lot of folks really don't pay attention to when they should.
Is it just cutting corners, or do they just not?
No, I wouldn't say it's cutting corners. Not at all. I just think it's, just like anything else, John, for almost 15 years now, and things have changed a lot since then, but a lot of it still has stayed the same, right? With regard to color measurement and methods that, people get in their set ways of doing things.
Yeah.
And of course it produces a good, maybe it produces a good product, right? But could you make that product better? Could you make that good product faster or cheaper? These are the things that really will carry you on into the future, is if you can do all these things, right? So sure, you can get by with doing it how you do it, but maybe there's a
Love that. All right. And I mean, I think we got to end on that. There may be a better way to do it. So you're looking at all these different aspects and dialing it in.
Yep.
So, thank you, Jonathan. This has been great. Thank you, everyone out there listening, attending, watching. If you have questions, I know we're about out of time here. If you have questions, hit reply to any of the marketing stuff you get from us via email. let me flip to this last slide. There's Jonathan's email address right there. Feel free to ping him directly. Yeah, and we got some more really good topics coming up around dispersion for the rest of the year. So there's one, I think our next one is in March. And I think we're off for a month or two, but we have a good series. You'll be notified and get those emails. So thank you for attending, Jonathan. Thank you for sharing your expertise and knowledge. Great
Appreciate
stuff. And have a great rest of your day, and we'll see you on future Bic Gardner web seminars. Thank you.